Sudhir, are you telling something because I'm not able to hear you?
Yeah, I think I was on mute. Sorry, guys. Okay, let me come back again. Okay, so here, if you see on the screen talks about a Docker Swarm cluster. So when you convert your normal Docker host missions into Docker Swarm, it creates an overlay networking automatically, and then it adds its own key value store in order to store the information of your cluster state and all. For that, it will use a raft algorithm. What is this raft algorithm means? On the manager node, wherever you're trying to execute some particular task, it will accept the API request, like whatever the command CLI command you pass, it will accept the API request, and then orchestration will try to object. It will try to create an object. Okay. After that, it will allocate an IP address, and then it will schedule to a specific node, and then it will dispatch. Means it will go to that particular node. Once it has reached to the worker node, it will, using the executor, it will try to create a what do you say, the task. Once it is done, it will give back the reply. Okay, that is the normal general procedure in the Docker Swarm cluster. Now, in the Docker Swarm cluster, it is creating its own overlay network in order to establish a communication between containers which are sitting on two different nodes. Okay, Docker host missions. Let's say I have a Docker host mission called Manoj, and I have a Docker host mission called Sudhir. Okay, now these two nodes are sitting on two different data centers. Let's say, for example, okay, now I want to establish a connection between uh, uh, these two containers which are sitting on two different host missions using a overlay networking. So I want to create my own overlay network due to some customizations and all. And for that reason, what we will try to do. Okay. So that is the main requirement for this. So now, so in order to achieve that, first we need to have a key value pair storage. Okay. So in order to have a key value pairs, we have different types of key value pairs supported. Like let's say, who's this? Sorry. Can someone please go on mute if you're not speaking to me? Okay, thank you. So Zookeeper, and we have console, and then we have etc. So these are the frequently used etcd storage service. Thank you. Yeah. So these are the frequently used key value pair storage. Key value pair storage, in the sense, it will store the metadata information of your cluster state or whatever it is. It will store the metadata information in JSON format. Okay. Now it will store the information in the form of JSON format. Okay. So in this example, I'm picking this console, which is a bit easy to configure and maintain it. Okay. But when you're working on production servers, it is better to use etcd, which has more advantages compared to any other key value store. Okay. So which is a recommended one by most of the, what do you say, most of the companies and all, which are preferred to use. If you look at OpenStack, if you look at Kubernetes, everybody is using etcd as a key value store. See, due to my limitations which I have, I'm using console. Okay. Now, for console to be installed, I took one particular mission. Okay. Let's say it is console, and the IP address are nothing but these missions. Let's say I have three missions right now. Let me draw the diagram. This is okay. So this is console, and let us say this is one Docker host mission. Let me note down the name. Let's say mission one. Okay. For our identification, just I have written the name like this. Two. Okay. Now let's say this is a Docker host mission 2, which means that Docker is installed. That's it. So simple it is. So these two missions where you have installed Docker. Okay. Now these three missions I connected to my own router. So it is a bridge network. I'm using a bridge. I'm not using any NAT or any host only adapter to have one for internet connectivity and one for internal communication. I'm not using like that. So all these three missions are connected to my bridge through bridge network to my router. Okay, how my base mission is connected. That is what I'm doing. Okay, now the IP address series is, let me note down the IP address series based on my router. So it is 192.168.1.130. So this is the IP address which I have allocated to the console. For this particular machine, I have allocated 192.168.1.131. Okay. And for this machine, I have allocated 192.168.1.132. Okay. So this is what I have allocated. Now these are the three missions, right? So now this is what I will do. I'll pick three missions, and in all the missions I have installed Ubuntu 18.04. Okay, here also I installed Ubuntu 18.04. Here also the same. Here also, okay. So these two are Docker missions, and this is a console key value pair store. Let me note down here saying that it's a key value pair store. Bit down. Okay. Key value store it is. Done. Key value store, right? So now these missions are connected with each other, and they can communicate with each other. Why? Because they are connected to the same network. Okay. So let us try. Let me show this particular thing first. So what I will do, I will pick this particular node. I will install console, and I will pick this particular node, two nodes, and I will install Docker on this particular two missions, and I will see the communication between them, and then we will start to create an overlay networking. Okay. So that is the first step which we will try to do. So now the concept is simple. Instead of relying on Docker Swarm overlay networking, we are trying to create our own overlay network. Okay, so to establish a connection between this VMs, which are sitting on two different containers, which are sitting on two different host machines. Okay, now let me tell you what other things I've done. See, in this POC servers, I have created three servers. Okay, if you look at these three servers, I took 4 GB of RAM for each and every machine since I have the flexibility of doing it. Anyway, I will reduce now. I'll make it 3 GB for each and every machine. That is more than enough for testing purpose. And that's it. One core CPU which is allocated, and Ubuntu operating system is installed, and it is connected to bridge. If you look at the networking part, I'll show one of the mission. If you look at networking, you can see it is a bridge network. Okay, connected to my main machine. Okay. That's how it is. And if you look, it's a 4 GB of RAM. I just want to reduce it right now. Okay, let's say I want to reduce it to, for console, I think it's 3 GB is like more than enough. Okay, for these two missions, I'll say like 3.5 GB or something, it's enough actually. Okay, so that I'll have enough amount of RAM on my base machine, which will be a bit easy. That's okay. Now done. Let me spin up these VMs. Okay. Any questions, just pitch in and just let me know. Okay. So
Sir, I joined a bit late. Okay, can you please explain, sir? 2 minutes.
see, simple. I just told that instead of using a Docker Swarm overlay networking, which means that Docker Swarm will create its own overlay network, and it will have its own key value store to store the information, metadata information of overlay networking. Now, instead of relying on that, if you want to create your custom overlay networking, so then what are the procedures we need to do? Okay, so for that we need to have one console server and two Docker host machines in order to test this particular overlay networking. Okay, so for that I spinned up these three VMs. I already created these three VMs. These three VMs have simple operating system like Ubuntu, and then which has a RAM like 3 GB, 4 GB or like that. Okay, it depends upon your base machine. Okay,
Okay,
so
okay,
that is one.
okay.
Yeah, once it is pinned up, then I will show you how to install this console, Docker, and all. Docker you already know. Most of the people, everybody knows this installation, but I need to do it. Okay, so SSH root at the rate 192.168.1.130 is one of the IP.
Sudhir?
Yeah.
Abhiram here.
Yeah.
Sudhir, when Docker Swarm itself is giving you an overlay network, why should I even choose another overlay network? What is the benefit?
Sometimes, let's say, this overlay networking, when you're trying to create, you might use some particular address subnet mask or something, okay, which is preferred for your, what do you say, based on your organization. You need to use that particular networking. Okay, it's a bit vast syllabus, but okay, I will simplify this. Let's say when you are using, why we are using this overlay network with custom, in the sense, I want to have my own key value pair store in such a way that I will store this information for later use or for backup and all. And if there is some customization which is getting conflict with my base operating system networking and all, so then I have to go for this customizations. Okay, having this own overlay networking and all. So this might be
By
future for your Kubernetes if you want to create your own overlay networking, or any other machine. If you take, if you want to create an overlay networking, this will be useful, because in this we will understand VXLAN and tagging and all. So this might be useful in future. Let's say in cloud providers, everybody is getting some IP address and everybody is able to communicate to the internet, and all this is happening because only you have this VXLAN tagging of your networking. Okay, it's bit vast syllabus, but it's like that. Okay, so when you have some tenant sitting on your networking, so we need to create an isolation between them, and but a connection should be established. Okay, so when there is a connection that should be established, it should be an L2 networking over L3. L3 should be there, right, when you want a communication between them. So I am using L2 network, but I want an L3 configuration, which means that which can be achieved through VXLAN. Okay, concept is that simple.
no. Can you explain that last statement?
Let's
Like
say
I have an
my particular systems are sitting on L2 networking, but I need to have L3 configuration for connectivity. Okay, so in order to do that, we need to use VXLAN. Okay,
but L2 itself is very straightforward, right? L2 is just a switch, and each switch, everything
yes.
is connected
Okay,
happily.
then how will you connect from one network to another network, which are sitting on two different data centers, or two different in same data center in two different racks, or in the same rack, or two different what do you say, bare metals and all.
Okay.
If you start thinking in that area, let's say you have two different data centers, right? In two different data centers, you have two different servers. Okay, you need to configure L2. Okay, which means that both the systems should be connected to the L2 network, but they need to have a connectivity. To be frank, they are sitting on two different data centers. How they will connect with each other? This switch is different, sitting on one data center, and
You are
this
saying L2. L2 means already they're connected, right?
L2, in the sense only it is connected to switch, but
Okay.
how you are establishing a connection? Okay.
They're connected to different switches. That's what you
Yes.
meant?
Yes.
Okay.
Different switches, but we are establishing a connection, which is possible only through VXLAN tagging and all. Okay. Tunneling. This is called as tunneling. We have GRE tunneling as well. VXLAN is more popular compared to GRE tunneling. Okay, which is more secured way to transfer the data.
Okay. Now, so that, yeah, by default, when I have Swarm, the IP addresses is something like 10.0.0.1, 2, 3, 4, something. Okay.
Yes.
It is already creating an overlay network. Why
Yes.
should I again create a new one?
See, let's say 10 dot series and all, it is having some, or in your overlay networking also, you can create your own specific IP address. Okay. The problem is with that specific IP address, I'm getting some conflict. Or let's say I want to connect through my switch. Let's say instead of using this, there will be some particular underground networking which will create some conflict. Or that is one thing, which means that which should not create a conflict to your overlay network which you are using in Docker Swarm. Okay, that is one scenario. And the second scenario is, if you want to store in your etcd storage, if you want to store this particular data in your own key value pair storages and all, I don't want to use inbuilt Docker Swarm key value pair store, which I cannot manage it. So then you can do it like this, in this way. Okay, which will simplify your job to have this particular connectivity information, encapsulation information, decapsulation. Okay, how many nodes are connected, everything will be stored in this particular scenario. Okay, the main concept is nothing but, when you use a Docker Swarm, how this networking came into picture and how this interfaces are connected to your container and how this connection is established. In order to show that and all, I'm creating my own networking as well, overlay networking from scratch. It is from scratch without depending on overlay networking of Docker Swarm. Okay, I'm not dependent on overlay networking of my Docker Swarm. I am creating my own overlay networking from scratch. That is the main goal of this. Okay.
Okay.
That is the purpose actually. Okay. So this is the mission which I have logged in. Okay, you can see the RAM which I have allocated and all. I think this is, you can see the host name. Just host name, I have not given some particular host name based on the application which we are trying to deploy, like console and all. I have not given like that. I just gave test server 1, second server will be test server 2, and third server will be test server 3. Okay, let us identify the first one as a console. 2 and 3 are for Docker host missions. Okay, I'll not change this name right now. Okay, I don't want to waste time on that. Okay, test 1, 2, 3, and then log into another mission as well. Test 1, 2, 3. Okay. Now these are the missions which are logged in. Let me try to see the communication. See, I'm able to connect to all the missions which I have. Anyway, 131 its own mission. See, so there is a connectivity between all these 3 missions. Everything is fine. So now I choose this particular mission in order to have this console installed. Okay, so let us say how to install console. In place of console, if you want, you can use etcd as well. Okay, for etcd also we have official document where you can install etcd as a standalone. But in real time, in production servers and all, to have high availability, they might be using let me show, where is it icon? Is the paint? Yeah. So you might use 3 consoles. See, 3 console missions, which means that high availability. If one of the console server is down, still you have 2 other missions which can have this particular overlay networking configured. Okay, and have this communication established. So high availability. So either you can achieve through console or through ZQ pair, or we can use etcd as well. Okay, high availability. So now since I have some limitations of creating these 3 servers of high availability, I'm using only one server as a standalone. Means I'm installing console as a standalone. Standalone in the sense which is installed only on one server. Okay, that is a technical term for understanding it. Standalone server. Okay, so I chose this particular mission in order to install console. Okay, so now you can follow the official document, or I already updated it here. I'm trying to install console by downloading the package. If you want to download, just go to the browser. You can see. So this console was like delivered by HashiCorp. HashiCorp has different tools. Okay, like and Vault and all. Okay, there are so many tools actually. Among this, we have this console as well. Okay, key value paste store. If you want to download the packages based on your operating system, you need to download it. Okay, since I'm using Linux, I selected that and I downloaded it. Okay, as simple as it is. Okay, now how did I clicked on this? Okay, cancel. You can see, right? I'm using the same one, zip file. So let me execute this. So now it is downloading the zip file. After that, we need to extract it. Means we need to unzip this particular file. So sometimes in Linux operating systems, you may not get the utility like to unzip. So we need to install the package, not execute the command called unzip. Okay. Sometimes it all depends upon the ISO which you are using. Okay. Let me try to unzip this. You can see it is downloaded. Okay. To unzip this, unzip, you can see it. There is no unzip. You need to install this particular package. So let me try to install this. Yeah, someone is asking something, or You can go on mute actually. Unzip, okay, and then console. So this is the zip package which you are trying to unzip it. Now if you see here, you have this unzipped utility. Now this is should be, it is a binary, so I need to copy it to binary locations. So obviously in order to execute this as a command, I need to copy it to the binary location. So I prefer to copy to user local bin. Okay, so let me try to move there. I'm moving it. Okay, so move to user local bin. Okay, to this. Now I can execute console commands. Console -help. Okay, so now you can see you are able to execute the command successfully. You are able to get the help output and all, which means that, or else you can check with -f version. Okay, to see like what version you have installed. Let me try to. Okay, this is how it is. Now I need to run my console as a standalone. Okay, so what I will do, there are different procedures to run it. Okay, either you can create a systemd service, or you can run it as a simple command, CLI command, so that you can throw that particular command in the background, so it will be running in the background as well. Okay, so the important thing for this console is nothing but the port numbers. The If you want to access the dashboard, or if you want to communicate to the console, the default port number is 8500. 8500 is a port number which is used to access the dashboard of your console or the communication as well. Okay, so let me try to spin up this particular console. Let me start this console service from the CLI instead of using systemd. If you want to start with systemd as well, I have documented here. I'll share with you guys. See, after doing this, okay, so what I have done, in order to see here, I'm creating this particular systemd service. I have added so many entries in the service file, and then I will start through systemctl start console and all. This is running successfully, but I don't want to use it. I just want to run this particular command. Okay, so what this command will do, this command, let me explain. Console, it is running as an agent in server mode. Server mode in the sense, now it will be a server as a standalone. Okay, standard. In order to tell it is a standalone, we have used this particular option called -dev. Okay, -ua in the sense, it should also launch the UI to access the dashboard of this particular console on the browser. Okay, so client in the sense, it is listening on all the IP addresses which I have on my machine, localhost and 192.168.1.130. Okay, and why I gave ampersand symbol at the last in the sense, in order to execute this command in the background. Okay, if I don't give anything like this, it will run in the foreground, means you cannot type anything actually. Okay, again you need to cancel this particular command which you executed, and then you need to re-execute it every time. So I don't want this to be happened. I want to do other task as well, right? Once this particular command was run, so in order to throw this particular command in the background, I give ampersand symbol. Okay, whatever command you want in future. Now you can see it is running in the background actually. Okay, I was able to execute the commands. Okay, now let me go to the browser and let me show you the dashboard. And 85/UI. This is the endpoint to access your console. Okay, now you can see console 1 instance, and you can see the console details and the IP address. Okay, you can see it is health, surf health status. Okay, agent alive and reachable, which means that you are ready to access this particular console, which means that it is healthy as well. Okay, so now the main important parameters is nothing but when you use console, okay, the node details will be present here. Okay, node details. Okay, so your Docker host nodes details will be present here. You can see here actually. Okay, and key value pair storage in the sense, when you insert the particular nodes in the overlay mode, okay, when you're using console for overlay networking for your Docker, what do you say, Docker host machine, then you can see these particular details placed in this particular key value store. Okay, As of now, it is empty because we have not used anything. It is just a console which we have initiated. Now, let us jump into the next other two nodes and let us try to install Docker on this particular two meshes. Maybe it is repetitive for you. Let me try to do it fast.
On server one, do you have Docker or you just
No,
have
no,
console?
nothing. Just a console. That's it. If not, I would have told you. Just a plain Ubuntu operating system in server mode. I have not used any desktop version, server edition, and I have installed. And then after that, I have installed console in right now. Okay, that's it. Let me try to go. Yeah, update is already done, so I don't want to repeat that. Here also. So this commands you already know. I don't want to repeat again, but already I will tell you this is nothing but it is installing the prerequisite packages. After that, I'm downloading the ZPC key before creating the repository. Yeah. On this node also, let me try to do this. Done. Now, let me try to add the repository to install the Docker packages. So it's a Docker repository. You're also same. Now you have key, ZPC key, and your repository to download the packages. So I'm good to install the Docker packages. Okay. So update is not needed. Why? Because nowadays this particular repository is executing apt command once a repository was added into the /etc apt source.list file. You can see the output. Okay, nowadays it is not needed to run apt update command once this particular repository was created. Okay, so now let us try to install these packages. Hope you understood. Earlier what happened when you create a repository in Ubuntu operating systems, you need to execute apt command. Then only that repository will get activated and it will get updated into your apt database. Okay. So now it is not needed actually. Just a small hint. Let it get installed. It will take few minutes. It depends upon the internet connectivity. Okay. Based on my internet connectivity, it will take another few minutes actually to complete. The concept is simple. I'm not using Docker Swarm. I'm not converting my Docker host machines into Docker Swarm to achieve the overlay networking. I'm using as it is. My Docker engines are as it is. There are Docker engines, but I'm using an overlay network. Okay, that is one more point which you have to remember. So for me to achieve the Docker Swarm, to achieve the overlay networking, earlier we used to convert your Docker engines into Docker Swarm. Okay, and then you need to create a overlay network. Okay, now it's not like that. So we are using Docker engines as a Docker engines, but we are trying to create a overlay network.
Sudhir, your voice is breaking up.
Is that okay now? Or still the same thing?
Yeah, now it's okay.
Okay.
Yeah, but Sudhir, don't you think there are, see, Docker Swarm, it just not only brings advantage of networking, but there is also TLS encryption, security, all that stuff that comes into the scope.
Up to us.
Don't you think we'll miss all that if we do this route?
The concept is simple. Let's say I have my application setting on two different Docker engines, but I want to establish a connection between these two. Then what is what I need to do? I don't want to use any encryption or any Docker Swarm advantages and all. Just I want to establish a connection from one particular container sitting on one Docker host machine and to establish a connection to another Docker host machine sitting on another machine. So how I can achieve this? So I don't want to use Docker Swarm because I don't want to enable any other parameters. Okay. I just want to only establish a connection. Then this is the solution which you need to achieve. Okay.
Do they do this practice in production? Any production systems that you have seen?
Not in Docker actually, because nowadays Docker itself they are not using, right? Only Kubernetes. Okay. So This overlay networking may be in future if you want a connectivity between the application for testing or for migration or something, it might be useful, but long run, it may not. No.
Okay. Yeah, Kubernetes is still more powerful,
Kubernetes
right?
itself is more powerful. It is also using overlay networking. Okay.
Okay.
By default, Flannel and Calico are creating this overlay networking and all.
Okay.
Based on this same concept, but it will be in a different naming convention, additional parameters and all. So those are the additional things which will be available, but ultimately it is the same. Okay, overlay networking, wherever you try to create, it's the same. And even Kubernetes also is using overlay networking in order to establish a connection, a pod. So that's the reason you are able to connect to your pod from one particular worker node or from the manager, from wherever you want, you can ping within the cluster. Okay. Let's try to see. Yeah, now the Docker was installed. Let me try to verify the version of the Docker which I installed. Okay, you can see 19.03.12. Okay, done. So now I've installed all the things which I needed for this particular overlay networking. Now what I need to do. So you can see this particular Docker networking, Docker network ls. You can see there is no overlay network right now. And my Docker was not even in the swarm mode. Just to verify. Okay. Did I enable the swarm mode? No, it is inactive. And on this particular Docker host, second Docker host machine as well, if you execute Docker network ls, okay, nothing was there regarding to overlay. And if you execute Docker info command, I don't have anything related to swarm mode. Okay, but still I want to achieve the overlay networking. So let us see how to do that. Okay, these things are you already know. If I try to create a container here, and if I try to create container here, this two doesn't have any connectivity. Okay, those are individual that you already know. No need to show the practical work of it. Okay, so let us try to now. We installed console, everything was done, Docker installation was done. Let us do one thing. Let us try to create a overlay network. Okay, so I'm creating an overlay network with this particular network series. Okay, let's say 192.168.0.0/24, which is not even conflicting with my base networking and all. My base networking is 192.168.1.0/24. You can see my VMs are connected to this particular network series, subnet 192.168.1.0/24, and I am using 192.168.0.0/24. Okay, and the name of this particular overlay network I gave visual path. See, I'm doing on only on one particular Docker host machine. Say I logged into the first Docker host machine and I'm trying to execute this. Okay. Just a second, guys. Why it is asking swarm mode? Okay, silly mistake actually. Okay. Now, how your Docker will know that there is a console key value pair storage to create this particular overlay networking. Okay. So the silly mistake what I have done is nothing but I installed Docker host. But for my Docker host, I need to tell this is your key value pair storage to save the information. So what I need to do for that, I need to stop the Docker service. Okay. Systemctl stop Docker. Okay. Once you stop your Docker, go to the service. Service related information will be present here. Come here, just add the parameter which I tell you, but let me explain this. Okay. I'll tell you what is this. There are two important parameters. So here, this first one is nothing but the IP address of my console. And this is the port number 8500. You can see here. Cluster store in the sense where you want to store this cluster information. Okay. A key value based storage is called console. If it is etcd, we need to write etcd here. Okay. Since I'm using console, it is console : // 192.168.1.30. 130 is my server where I've installed console and the port number. And there is one more parameter called cluster advertise, means on your Docker host machine, which interface you want to use for communication to the console. For that, I'm using enp0s3. If you go to the second node, if you execute IP space a command, instead of giving the IP address, I'm giving this enp0s3 interface. Can someone tell me what is the advantage of saying like this instead of specifying the IP address?
So whatever
It is
IP
having the
In case
multiple
IP
IP
address
address.
changes,
Yeah.
in case of IP address changes on
In
interface,
case tomorrow, if I want to change this IP address from 132 to something else, it should not affect my cluster or my Docker storage cluster and all. So for that case, I gave my interface name instead of the IP address. Okay, that is the only advantage which I will give this particular way of giving this interface name. And 2376 is something when you are trying to communicate to your console. So this is the port number which is used to communicate. Okay, 2376. Okay, and then containerd is this additional option which is already there. The only two parameters which I added is nothing but cluster store is equal to that particular IP address of the console and the port number. Cluster advertise in the sense on which port number, on which interface this communication should happen to the console. So I'm using enp0s3 interface. In your case, it can be eth0 or something like this. First, see what is your interface name and then add that particular interface name over here. Don't add same thing, same interface name, whatever I have added. First, see what is your interface name on the host machine. Okay, then add it. Okay. So once it is done, just save this and come out. Okay. After that, first thing what I need to do is like daemon reload. Okay. After this, I need to start my Docker. Okay. Now let us verify the status and see whether it is. You can see the details are accepted. Everything is running right now and it is in active state. If you go to the dashboard, if you refresh this, if you go to the nodes, you can see, I think nodes are not added right as of now, I guess. Yeah. So it is still not detected. Okay. Anyways, so as of now, it is not detected. Let me refresh this. Let me go to Docker nodes. You can see here, you can see it. Till now, this particular key value pairs storage is empty. Now, once I added my first Docker host machine to the key value pairs storage, means like when I added it, automatically you can see my under node details, I can see my 192.168.1.131.276 was detected. Okay, it is under key value pair store. You need to go to Docker and then go to nodes, and then you can see here. Okay, let me add the second node as well with the same strategy. Okay, first what we need to do, go to that particular node, stop the Docker service, Docker, and after that open the service file, Docker service. Okay, go to this line, exe start. Before this container D, just add this particular parameter. Here same. Okay, just save this file and come out, and after this just do a system reload, daemon reload, and after this restart. See, whenever you do some changes in the service files, well, it can be any service file. First thing is like you need to reload your daemon, and after that you need to start your service. That is a normal general procedure which we need to do, whether it is a production or anything. Okay, start Docker. Let us verify the status. You can see it is up and running. It has not created any issue while starting this particular node. Okay. Now if you go back and if you refresh this, now you need to see two nodes. So you can see now. So these two nodes are detected in your console, which means that you are able to establish a connection to the console, and console was able to detect your node details and all. Okay. Now coming to the networking. So now let us try to create our own overlay networking without using Docker Swarm. Okay. I have not used any Docker Swarm right now. I have not enabled it. Okay. Let me try to create this particular network, overlay network. It has to be created successfully. Now you can say it is created successfully. Earlier, what happened? It has thrown me error saying that it is now a Docker Swarm added. So just execute Docker Swarm init or Docker Swarm join. But I don't want to use the Docker Swarm. Without using Docker Swarm, I want to establish a connection between the applications sitting on two different nodes. Okay. For that, I added my particular Docker host machine to the console. Once it is added, I was able to create the network. Now, there is one thing which you need to observe is nothing but Docker network ls. Now you can see overlay network was created. The same overlay network will be visible on this particular node as well. Docker network ls. You can see this. Okay, did I create it on this? You can see the ID as well. Both will have the same ID. 583C837DCA843. Okay, you can see 84358C837DCA. Same. Okay, since we are using console, right? Obviously, it will get replicated. Okay, how we have a database replication, right? Which means that if we try to create a database in one node, automatically it will get replicated into other two nodes, which are formed as a cluster, similar to that. Okay. Now, what we will do for testing purpose, in order to see whether you are able to communicate and all this XYZ testing or not. Okay. In order to do that, what I will do, first I will create a container, okay, on one particular node, and then you can see now what I'm trying to do. I logged into 131 Docker host machine. I have two Docker host machines, right? 131 and 132. Now on 131, I'm trying to create a container with this image called Ubuntu 18.04, and I'm specifying the network called visual path, which means that it is an overlay network. Okay. If you go back and see the history, visual path is nothing but my overlay network, right? And you can see I want to use a specific IP address. Okay. 0.10. Okay. Let us try to create. If this image is not there, it will try to download and install. If you go to this node, this is the entry. Okay, if you want to modify something, you can modify it and you can save it. Okay, but don't modify anything. Docker. Once your network is created, right, go to the network and you can see v10 and you can see something like overlay. In overlay networking, just click on this. This is the ID. Same ID, right? 853S83. It is a long ID. If you try to compare this, there is ID. Copy this. Same ID, right? That's how it is. Just click on this. If you want, you can download this actually. Download document of KYC or read the guide. If you want, you can download. Okay. Now, yeah, now we created a container, right? So this container is running. Let's see. You can see this particular container is running. Now, what I want to do on the second node, Docker host machine, I just want to create a temporary container and I want to just try to ping that particular container, which is sitting on another node. Okay. But this container should also launch in the same overlay networking. Okay. That's one thing you have to take care of. Now, let me try to create another node on that particular. I'm not specifying what specific IP address I want for this particular node container because it is a testing purpose. So I'm not worried about specific IP address, but I'm worried about creating this particular container with overlay networking. You can see -FN RM in the sense once my task is done, once I exit from that particular container, it should delete that particular container automatically. If you don't want to do that, you can remove that -FN RM. hyphen net in the sense network. What network you want to use in order to create this particular container overlay. Okay, then enter. This image is also not there on the second node, so it is downloading that first and then it will create the container. After this is created, then I will try to use a ping command in order to try to communicate with that particular container which is sitting on another node. Okay. Okay. Now try to use ping command is already there here. Okay, no need to install from our side. Ping 192.168.0.10. That is an IP which was assigned to this particular container. All right. Okay. So let's try to ping. You can see you are able to send the packets. 0% packet loss. Let us log into this container and see how this networking looks. How many interfaces you will have. Okay. What is the IP address you will get for that particular interface. Generally in container, what is the interface you will see? You will see the interface only one interface, and that too the IP address which you will get from the bridge network, right? Now let us log into this particular container. You can log in to this container or in this container as well. Both are accepted. Okay. Let us see the networking part. Docker exec-ti. Let's give the name like source. This is the container name and bash. You logged in. Let me execute IP space A command. Oh, I think it is not installed. Let me go back to this. Let me try to install if not. apt IP route 2 and I want to install IP utils -ping package as well. Okay. In this Ubuntu image, I don't have these packages, but in Debian image, I have these packages. Okay. If you see, look at this particular container as well. Now you will see two interfaces. One interface is getting an IP address from that particular overlay networking. And the second interface, you can see it is getting an IP address from the bridge. Okay. Let me show you that particular bridge. Let me exit from this. Okay. If you look at the Docker network ls command, you can see this particular Docker bridge was created. Every Docker host machine has its own Docker bridge. Okay. So this is not something a overlay. You can see that, look at this ID and log into this particular Docker host machine and look at the ID. Okay, both will be different. Let me try to exit from here. So Docker network ls. You can see the ID. This ID and this ID is different. Okay, which means that those are separate. Okay. Now let me go back to this particular node. Now if you execute IP space A command, what happened to the packages? Okay, IP route. Now, if you execute IP space A command, you can see here also we have two interfaces. But this container got an IP address called 192.168.0.10, which I specifically mentioned that I want this IP address. And this was automatically assigned 0.2. Okay. And you can see here we have 172.18.0.2. And here also we have 172.18.0.2. If you try to ping on this IP, it will not communicate, obviously. Okay. So let us dig into the networking part right now. If you execute IP space route command, you can see whether this interface or whether this interface, if you try to communicate to the external world, it will pass only through this particular IP address. Okay. Through this particular ETH1 interface, you are able to communicate to the outside world. Okay. If you try to use a ping, google.com, okay, it is able to connect to the internet. But this will try to pass the information through ETH1 interface. it looks like this in a diagram. Let me open that. If you open the diagram, now how to draw this? Okay, and there are two interfaces. Okay, in this container we have created a in this particular Docker host machine we created a container. This container has two interfaces. Let me remove this everything. Let me explain this. Let's say this is your Docker host machine, and in this you have a container. Okay, for this container it has two interfaces. Okay, so this is called source container. Okay, on the base machine you have one interface. That interface is called as enp0s3. Okay, now you created one it has one bridge interface and one overlay networking. Okay, so both will communicate to this particular interface. Okay, but okay, let me note down the naming convention. ETH one is ETH1. This is ETH1 actually, and this is ETH0. Overlay network is ETH0. Now, what I'm trying to say is nothing but this particular interface has an IP address called 172.172.18.0.2/24. Okay, and this particular interface is having 192.168.0.10/24. Okay, and this is connected to another machine. Okay, and this interface will be connected to the external world, which means that it can communicate to the internet. So that's the reason if we try to use a ping here, okay, the packets will flow from this particular interface to the base interface, and then it will go to the external world, and then it is able to communicate to the internet. Okay, one thing I can show you is nothing but, let me try to ping to this particular container IP address. Okay, see what will happen. Let me come out of this. So that's a details. Okay, if you come back, if you come out of this, if you use 192.168.0.10 and try to ping, it will not accept, because your Docker doesn't know this where this interface is. Okay, only your namespace knows, and your overlay networking knows where this particular interface is there. Okay, so that's the reason if you try to ping this particular IP, you are not able to do it. Now let me try to ping 172.18.0.2. You are able to communicate. Okay, so that's the one thing you have to observe. 0% packet loss. Okay, so that is the one thing. So you cannot communicate to the overlay IP address from the base machine, but from one container to another container you are able to establish the connection. Okay, if I try to ping from one container which is sitting on another machine, try to ping this 192.168.0.10, it was able to communicate, which we have seen last time. Okay, so this communication was happening. Okay, that is one thing we have to remember. Okay, now, so which means that with this interface you will communicate to the external world. With this interface you are able to communicate to the other applications which are sitting on rest of the Docker host machines. Okay, so that is the one thing we have to remember. So here let us try to analyze the interfaces and how this namespace was created. Whenever you create a container, this container will have a namespace. Okay, so in this namespace, one end will be connected to the container and second end will be connected to your bridge network. Okay, that is a normal kind of networking actually, which is with pair, which is called as with pair. With pair in the sense it looks like this. Okay, this is how it looks. So one interface was able to communicate to the external world. That is nothing but the 172.18.0 series, which is able to communicate to the external world. But this interface is using this interface to communicate to the other interface which are sitting on this particular Docker host machine. This is the overlay communication which was happening right now, which is doing through console. Okay, console was able to do it. How and all, let us see later. But this is how the communication was happening. So Using this interface, you cannot communicate to the external world, or from the base machine, you cannot communicate to this particular interface. It is not allowed. Okay. Only this interface is used to communicate to the external world, or you can communicate to this particular container using this IP address. That's it. Okay. This is only for communication between a container which is sitting on two different host machines. Okay. That is the purpose of overlay networking right now. So that is experiment which we have seen right now. Okay. So let us go back to this. Yeah. Now let us try to understand the namespaces. How to identify your namespace and how to see the details of your networking namespace. Okay. So in order to know your network namespace, okay, how it is created, where it is there, okay, you need to inspect your Docker container which you have created. Now this is the container which I have created, right? This is the container which I have created. Take this particular ID or the name of the container and let us execute this command. Give this ID, or I've already given the container name here. Okay, so just execute this command. You can see you got this particular details. If you try to execute ls-l command over here, you can see there are two different IDs. Okay, first let us try to analyze what is the information that is stored in this particular network namespace. There are two network namespace IDs. Let us try to analyze this first. Okay, so in order to analyze this particular network namespace details, we need to use a tool called, either you can use IPNetNS, okay, or we can use this particular command, okay, ns enter. So this is the utility which we are using right now. Okay, so using this particular command, I will try to show you the details of this particular network namespace ID. Okay, so the ID is, let me try to replace the ID. So okay, with this network namespace, I can see my, how I'm able to see, log into my container and see the interface details and all. Without logging into the container also, we can see the network related information of that particular container using this command. Just you need to get the ID and just give that ns enter, means network namespace enter hyphen network is equal to that particular path IP space ADDR. When I execute this command, in that particular network namespace, whatever the details are there, that particular interface details will be shown. You can see the details. Okay, so you can see the ETH0, the IP address, and ETH1, the IP address. If you log into the container also, you can see the same details. See IP space A command. Same details or not? Okay. So this is the one thing. So this is the important tool when you are working with network namespaces. NS enter, or you can use IP space and net NS. Both the commands can be used. Okay. So I think with the network namespace, let me try to do this. Yeah, for this I need to follow a different approach. Let us ignore this right now. Okay. So by using this particular command, I used ns enter, which is nothing but network namespace enter, and then we are given the network path, where is this particular ID, and we have given IP space ADDR command. So these details are fine for us. Okay. So with this, we have seen the network details and all, and let us execute this particular command. So this command will tell you what is the prefix links of that particular interface, which means that, let me try to tell you one thing. Let me take this ID. This is showing me the prefix index ID. This is nothing but 7. 7 in the sense, this particular ID belongs to this particular, you can see here, if 7. Okay, so this is the ID, peer if ID, interface ID. Okay, how we are able to get it? Same command, instead of IP space ADDR, just I need to give ETH2, ETH2 hyphen capital S and ETH0. ETH0 in the sense, this is the interface. So it will print the ID of this particular interface. Similarly, if you want to give ETH1, you can give this. It is 10. 10 in the sense, you can see here, interface. Okay. On the base machine, if you try to execute IP space A command, you can see that particular interface details, 10. Okay. But only one thing which you will not able to see is nothing but this overlay network related information. Are you able to see anything like 7? No, right? So those interface details you will not able to see in this particular base machine. Okay, that is the one thing which you need to observe. The bridge network which was created by the Docker, that interface details, the V pair details can be seen in the base machine. Okay, V pair in the sense, this V pair is nothing but like this. Okay, this is the connection. So one end is connected to this particular IP interface, and the second end is connected to the bridge network called 172.18.0.1/24 series. Okay, so that's how the networking was established. Okay, and if you look at this particular second interface, let us try to analyze the details of this particular interface. Now, if you go back to the diagram, this is how it looks. Okay, this is how it is looking. With pair in the sense, one end is connected to here, and the second end is connected, means namespace actually. Okay, in the container namespace, one end will be connected to by with pair, and in the Docker namespace, it will be connected with second end. Okay, that's how it is. And this with pair, let us try to analyze the details of this particular network. Okay, first we have seen this particular one, and let us try to analyze this. Let me try to pick the details of this interface. Where is that? Yeah, this one. You can see. Now you will see a slight different details. That is nothing but BR0 bridge. Okay, and VXLAN. Okay, so VXLAN 0, and if interface name is 5, and V pair 0, interface number 6. Okay, so these are the details which you are able to see. So those details you cannot see in this particular base machine. Are you able to see it? No. Okay, so these are created in separate namespace. Okay, which means that this particular details will be present on different namespace, which means that this with pair, okay, a connection, it looks like this actually. Okay, it looks like this now. So there is a with pair which will establish a connection between the bridge called BR0 and net container namespace. Okay, so this will be used as a connectivity, like a cable. Okay, so this will look like a cable connection between the container and the BR0 bridge. Okay, and from the BR0 to the base machine, it will look like this. So this will be the actual interface, VXLAN. Okay, so this is how it is. This is how it looks. Okay, so the with pair is a connection between the Docker container namespace and the BR0, and VXLAN is a connectivity between the BR0 and the other interfaces. Okay, so now when I try to use a ping, how this data will get transferred? Okay, it looks like this. Okay, the original layer 2, which means that the actual IP address of 192.168.0.0/24 series, VXLAN header, in the sense every VXLAN will have some ID. Generally, before VXLAN, we used to have VLAN, virtual LAN. Okay, the virtual LAN has a limitation of we can create only 4096 IDs, not more than that. This has created, for our testing purpose also, we can use VLAN. Okay, but in real time, when you go to AWS and all, Google Cloud or Azure or OpenStack Cloud and all, they will use VXLAN. Why? Because 4096 number of IDs are not at all sufficient for tenant networking and all. So for that, they use some huge networking. So in order to use huge networking, we need to go for VXLAN. So VXLAN will support how many IDs? It will support 16 million IDs actually. So which is far away from VLAN, right? VLAN supports only 4096 number of IDs. Okay, to create a two different what do you say network interfaces and all. Okay, so totally we can create only 4096 interfaces. But whereas in VXLAN we can create 16 million. Okay, imagine. So that is more than enough. So for every interface, it will have some ID. So that ID will be added to the packet. So this is a packet. Let us assume this is a packet. When you're trying to send a packet from this particular container to this container, it will look like this. Original L2 in the sense, this is your L2. Okay. L2 network in the sense that is 192.168.0.0/24. Okay. And VXLAN header means every VXLAN will have some ID, that particular ID. Okay, UDP destination in the sense, when you're trying to establish a connection from this particular interface to this interface or over a VXLAN will use an IP port number called 4789 to reach to the destination. Okay, and then the outer IP address. Outer IP address in the sense, the base mission IP address 10.0.0.10 and 10.0.0.11. So this will be used, right, in order to communicate between these two. So that's the reason I told you, like, VXLAN is nothing but an L2 networking or to have a connectivity over L3. Okay. So L3 is used to pass information from one particular container to another container, but underlying it is on the same L2 network. Okay. So that's how it is. So it looks like this. When you send a packet, it is the actual frame. So original L2 in the sense, this is the one. Okay, this IP address series is nothing but your source to the destination. And the VXLAN will have some ID, VNI. I'll show you how to see that. And the UDP is nothing but we are trying to send some particular port number, that is a random port, and then to the destination using 4789. That is same thing, whether you try to ping from here to here or whether you try to ping from here to there, the destination port number will be used as 4789. And the original IP address to transfer the information. It will be obviously L3. Why? Because in order to pass the information from here to here, we are using router. See, my base missions are connected, my Docker host missions are connected to the router. So obviously it will reach through router, but the packet will look like this. It is not a normal packet. Okay, it will have VXLAN ID, UDP port number, and the original IP address to reach the destination. Okay, I'll tell you how it looks. When you try to send a packet, it will add this particular frame till here. It will come out of this using this particular frame. Once it is reached to the destination, it will decapsulate. So here it will encapsulate. And once it is reached to the destination, because you have written the destination like 10.0.0.10. Once it is reached to the destination, okay, the UDP, this particular things will get decapsulated, and the original IP address it will see, the destination IP address, and then it will reach to there. That's how it is. So it is as simple as it is. Okay. So this is how the communication was established using VXLAN. If you want to see how these packets are flowing, let me do one thing. This is there already. I will open two terminals of this particular Docker host machine, and I will show you one thing. Let me open another terminal for second Docker host machine. It is 132. Yeah, 132. I will show you the packets of TCP dump, or I can show you the packets. Okay, no need of this things actually. Let me try to use this command. I think TCP dump is there. Yeah. Let me try to execute this command over here. Okay. From this second container, so second Docker host machine, I will try to ping to that particular container. Okay. So ping 192.168.0.10. And let us try to analyze the packets, okay, which are coming to this particular interface. You can see. Let us try to analyze this. So if you look at this, this is the IP address. Can someone tell me what is this IP address? From where is this?
Overlay IP address that was assigned to the
container, right? We created this container, right? So this container was assigned with an IP address called 192.168.0.2. So from there, we got the IP address and then it reached to this particular 192.168.0.10. Before that, if you observe this packet carefully, before that what happened, you can see the IP address 192.168.1.132. Okay, this particular packet, I'm talking about this packet, okay. So this packet was, this one, okay. So this one was opened a random port number, but you can see it is reached the destination using this particular port number, okay. There it opened. So here it opened some random port number, but it reached here using this particular port number 4789. It is a UDP port number, UDP protocol port number 4789 when you use VXLAN. So how to identify whether it is VXLAN or not, you can see here VXLAN and the ID is 256 VNI. I told you header, right? VXLAN VNI ID. So this ID is nothing but 256. Okay. So once it is reached, means once a packet has reached from this outer interface to the inner interface, it is able to communicate between these two interfaces. Okay. How you can see this? 192.168.0.2 is able to reach to this particular IP address using ICMP protocol. Echo request. Okay. That is echo request. So in order to get a reply, you can see now 192.168.1.131 means this one. See, initially it is from 132 to 131. Now it is sending a response. Okay. Now it will be from 131 to 132. Okay. So when it is sending a reply from here to there, now this destination is this. So the destination packet will be 4789 port number, reverse order. Okay. So once it is reached there, then it is sending the reply from 192.168.10.0.10 to 192.168.0.2 echo reply. That's it. If you analyze this one packet, that is more than enough. These details. Send the request, then VXLAN came into picture. Once it is reached from one node to another node, internally it was able to communicate with overlay networking. That's it. Okay. The important point is nothing but when it's sending a packet from here to here, it is using the source with a random port number and the destination is 4789. Let's say from here to here. So from here, we are trying to ping 192.168.0.10, 100. Let's say 100, instead of 100, we use 10. Okay. So this is the original L2. This is VLAN ID. So this ID is used to reach to the destination. So it has opened a random port number to reach to the destination port number called 4789. Once it is reached, then these two are able to communicate with the ping protocol. Okay. So this is how you can analyze the packet flow using TCP dump command.
Somebody posted a comment saying, where did you execute the TCP dump? We could actually execute
This was
in any...
executed on the Docker host machine 1, where you are trying to reach. Let's say this is my container. Okay. So this, from this container, I'm trying to reach to this particular container. Okay. You can execute TCP dump on this particular node, or you can execute TCP dump on this particular node as well. See, let me try to execute this.
Yeah, but on the other one, you'll see the request response a little
in a different way. Okay.
Yeah.
The source and
Now,
destination will change. If you analyze this packet, right? First, it is trying to send a request from 132. Earlier, what happened? You can see it is sending from 132 as well. So from wherever you see, it is the same details. VNI interface, you can see 256. Same VNI. VNI is virtual network interface. For virtual network interface, it has generated some ID. Okay, your VXLAN interface, BR0 interface and all, this will be seen only in the namespace. Okay, so these details you can see only on this particular namespace using this particular command. You cannot see on the base machine or in the container. Okay, so that is the one thing you have to remember. So this is all about your networking of overlay, which we have created on our own. Okay, so maybe next time I will try to elaborate more about VXLAN. But as of now, if you want to create your own overlay networking without using Docker Swarm, so this is the one. Now we have seen through console. If someone wants to try through etcd, you can follow the document. Same document, just you need to same commands. Okay, I'll tell you only one parameter which will get changed in the Docker service, right? You will update your cluster store and all details, these details, right? Okay, same parameters, same options. This will also be same. The only thing is like instead of console, it will be etcd, and the port number will be slight different. Okay, that is the only change. Create a etcd with standalone. Once it is done, once you feel that it is running fine, then you can follow the same steps. Okay, I tried with console, try with etcd. If you're facing some challenges, let me know. I'll tell you like how to do it or how to fix it. Okay, any questions?